Howdy folks, RC Helicopter Build Day today. A few days back I did an unboxing of this Devil 505 helicopter kit, and today we're going to be putting it together. And I'm one of those people who find building an RC helicopter kit probably one of the best parts of the entire hobby. To do this, what I thought I'd do is, instead of bore you with a 4-hour build video or however long it's going to take, I thought after each main step of the build I'd do a short little summary video of putting that section of the kit together. And that way, I think that'll give you the best bang for the buck as far as information for time spent watching. As far as tools to put this bad boy together, just the basic normal stuff that you need for any heli build. Metric hex drivers, pliers, side cutters, ball link pliers, hobby knife, screwdriver set, all the basics. As far as consumables go, you're going to need Loctite. 648 is a retaining compound. We need that to fasten the bearing races into the grips and into the bearing trays for the main shaft. You're going to need thread lock. I've got 242 here. 243 is better if you've got it. It's not as susceptible to oil contamination. A lot of times the fasteners have machining oil on them, so with the 242 you just have to clean it off, and that's why I have brake clean. I clean all my fasteners off with brake clean if I suspect there being oil on them. If you've done heli builds before, you've probably already got, these are Align bottles. They've got the T43 thread lock and the R48 retaining compound. Greases, oils, whatever you use. I have the Align silicone bearing grease, and I just use regular bearing grease for thrust bearings. CA glue, I've got thin and medium there. Don't know what will you need, but shows that in the instructions. And yeah, certainly speaking of the instructions, you're going to need to download the 505 instructions. I'm going to put a link down below in the description so you can get those. It's a 41-page instruction manual. Very straightforward kind of stuff. There it tells you all the consumables you need, and as far as the instructions to put it together, it's just showing exploded CAD parts diagrams of the parts, how they go together, where the fasteners go. Very easy to follow, very clear. Frame assembly is together. Went really well, no hiccups at all. Fit and finish is really nice, so nothing really to report. The only thing that I had a little bit of adjustment to do was these little bevels for the front of the struts. These bevels, they don't have any notch or anything to lock their location. They'll pivot back and forth, and that will offset the angle here. So what I did is I mounted the back first of the strut, so it had its set angle, and then I just tweaked this so the strut was lying nice and flat against the full face of this little beveled piece. All the fasteners, there were no missing ones. As you can see, they all have the little anodized cup or beauty washers that go on them, so that's a nice little finishing touch. And the screws themselves, yeah, this was with brake clean. I don't know if you can see that. There is some machining oil on them, so if you're using Loctite 242, do recommend cleaning the machining oil off. Of course, that could just be anecdotal on my built kit, but I'm sure all of them have some machining oil on them. The other nice thing is there's these numbers up here, and they reference the bag number. So it's really easy to follow along. All the associated parts of that step use the parts of the bag number, and yeah, really easy to put together, really straightforward. Thought I'd point out one little oddity while doing the main structure here. The bearings went in fine with the retaining compound. It's these little spacer pins. They have slightly different diameters, top and bottom. Top is about 8 millimeters in diameter, and the bottom a little bit less, 795, 796. And what you'll find, at least on this one that I'm building, is these little holes will only accept the 795 diameter. just fit in nicely. They won't fit in the other way around. You'll probably drive them in, but they don't fit in those. But the 8s do fit in the upper tray assembly, the servo tray assembly, fine. These recesses are just over 8 millimeters, so they will fit in fine on the upper plate. Another item to note on the main gear here, it comes with the fasteners in, but these aren't tightened or thread locked, so you're gonna have to do all that. Yeah, you know, when in doubt, any heli build, if something's put together, check to see if it's tight and if it's had Loctite put on it. More times than not, probably isn't. Frame structures all together went together beautifully. Everything fit like a glove. Just a real pleasure to work on, to build. So really enjoying this build so far. Couple of things to note. They say that you may need a shim here. Every build's obviously going to be different, but mine didn't. There was no play in that shaft, so I didn't need a shim in there. On this motor pulley, this was all assembled, but these flange bearings didn't have any retaining compound on them. Just made sure the auto rotation or one-way bearing was oriented correctly. It was kind of nice to see. I didn't see the actual name brand, if it was an SKF, but it did have Germany printed on it, so they're not cheaping out on the auto bearing, which is nice. So had to put retaining compound on those 2 flange bearings on the pulley. These screws, everything was tight on the tail pulley, but the screws didn't have thread lock on them, so had to take all that out, clean the screws off with brake clean, blah blah blah. This all fit together nice. I did have to use that shim there. Oh, and where else? Another shim. I did have to use one shim here on the main mast to take out some play that was in there. So just a single shim. Chapter 21 to 25 of the build is now complete, mounting all the servos. Nothing really exciting to report, just followed the manual. Everything went together really nice, fit like a glove again. So impressed so far with the build. And these servos are really nice, really impressed with them. Full metal, the gearing is nice and smooth. There's no play at all. A few deviations from the manual. I haven't put the arm on the tail servo yet. I don't know what the centering is going to be yet until I hook it up to the FBL unit. So I'm not going to put that on, but at least you can access it really easy right through here. As far as mounting the tail servo, back screws were easy to mount through this slot. You can get to them super easy. Front one's no problem there. All these top ones, they're your 3 cyclics. I haven't mounted these solid yet because I'm going to have to be pulling these arms off before I hook it up to the FBL unit, before I power it up. I don't know if they're centered. A tip here is if you've got a 2.5 millimeter ball driver, hex ball driver, you can come in at these at an angle, which is really handy. You can't come in at them straight because the other servo is in the way. So a ball driver works great. A little hex, 2.5 Allen key would work too. You might have to chop the short bend a little shorter to get in there, but it'll, you'd just be turning it and turning it and turning it. Ball driver makes it a lot quicker. These are 120 degree ECCPM spaced. And the other thing, all 4 use regular Futaba 25T splined servo arms, so that's nice. Another neat thing is all the grommets on all 4 are silicone, and a silicone grommet. They'll last a lot longer than the rubber ones. Well, rubber gets hard, it cracks. Thought I'd better point out on the Swashplate, not a single ball or screw had thread lock on it, so you're going to have to take them all out, thread lock them. That includes the 2 swash half little screws. They didn't have any thread lock, nor did the 3 bearing retaining screws on the back side. If anyone's curious, all ball sizes are 4.7 millimeter. And like I said, the links, when we did the unboxing, really nice beefy links, and easy to tell which way they are directional, which way you can pop them on the ball. So the side that's got the ALZRC, that would be the outside. The side that you can pop over the ball doesn't have the writing, and it's actually got a little bit of a molding ring around it. So that's the side that you pop over the ball. Thought I'd mention a couple of things now that the swash is mounted. Anti-rotation brackets on, no big deal there. These links are so nice, not too tight, not too loose, just a really good fit, really beefy. When you thread them together, there's just going to be a slight little gap. The length they want is 44.5 millimeters, so get them all roughly there. But what I wanted to talk about was swash leveling tools for this thing. It's got a 10 millimeter mass, so essentially any 120 degree swash tool with a 10 mil hole should work okay. This is one of the Align ones. Most people have probably got or are familiar with these. It's a universal 550 to 800, so it will work. You know, the ears are a little bit too long for the swash plate, but you can still use it just by offsetting it a bit so you can get those ears resting on the metal part of the swash. You may be tempted to go onto the links, but don't. The linkage size, they're not quite exactly all the same, so if you were to level off of those links and then you rotate the swash so it's resting on the ears, you see we've got a gap back there. I don't know if you can see that. I've also got one, if anyone's got one of these 600 or 10 millimeter True Blood tools. These are wonderful swash tools. They're not available anymore, but really nice tool. Easier to use than the Align one because the pad isn't so big. It doesn't block as much of your view, but either will work fine. While I'm working on the rotor head, I just wanted to point out a couple of things. It comes all assembled, but yeah, you have to take it completely apart. Nothing's got bearing retaining compound or thread lock. The axle, head axle, or feathering shaft, I had to pull that out, lubed it up with silicone grease. There's two O-ring dampeners on either side. They have to be lubed up with silicone grease. The radio bearings, they have to be cleaned on the outside. Same with the inside of the blade grips to put your bearing retaining compound on there. The thrust bearings have to be packed, and like every heli that I know of, the thrust bearing, the inside race has got a slightly larger ID than the outside race. I can't visually detect it, so strongly recommend, if you don't have a set of digital calipers, pick some up. They're cheap enough, the cheapy ones, just so you can make sure that the smaller ID is on the outside and the larger is on the inside. The only other thing I wanted to point out here, just as I was doing this blade grip, as I was screwing the arm on, is just how great the fit is. There's zero play in there. Just, shows you the extreme quality of this kit. I'm so impressed. Head is now finished. Came out really well. I don't have this securely mounted yet. I'll be taking it off right away. I want to check the blade balance, and to do that I want to do that on the head with a high point balancer. And plus I have to take it off anyways to correctly level the swash plate while I'm configuring the FBL unit. As far as head geometry goes though, with the recommended pushrod lengths, I think you can tell it's pretty much very close. Our washout arms are nice and level. Our blade indicators are pretty much at zero. So we know that the factory push rods are pretty darn close. They'll just take a little bit of tweaking. Couple of things on the head though. In the instructions, this head, when I took it apart, it had two of the O-rings, and it didn't have this, they call it a spindle shaft damper rubber. It's actually a hard ring of plastic. Now, I have never seen mixing two different hardness dampeners in a head. I've never seen that before in my 30 years in the hobby. So I have left it with the two O-rings. Now, maybe that's a mistake. I don't fly hard 3D though, but I see no why you would have dual hardness dampeners. Up to you guys if you want to go with the instructions or go with how it comes out of the bag. Probably a lot has to do with how firm or how soft you want your dampening. And the other thing, the washout arms themselves, when I tightened both of them down, the bearings were overly preloaded. It was really notchy. You could tell the bearings were under a lot of side pressure. So there's two ways to deal with that. One is to put a shim between the little brass spacer in there, or two is to reduce the width of the arm. and I chose the later. I rubbed both sides, just a couple of light passes on some sandpaper just to knock any high edges down so the flange bearings would sit a little bit closer, and that was enough to take the preload out. And now I could snug those right down and they're still nice and free to move. No bearing notchiness there. So that's pretty much it for tonight. It's, what do we got here? 11:20. Time for bed. Looking forward. Can't wait till tomorrow evening to start back on it. We'll be on chapter 37. You guys, of course, don't have to wait. See you tomorrow night. Welcome back to night 2 of our build. Just doing our blade balancing and CG checking now. So I've got the blade bolt holes, suspending them with a driver, and I've balanced the blades on a mast to find the center of gravity. As you can see, where the CG on both blades is matched up, so CG is on the mark. Before mounting the blades in the balancer, I thought I'd talk about the root thickness a bit. Root thickness on these things, basically 10 millimeters. Interesting though is the grip thickness is about 12. Luckily it ships with 4 spacer washers, which should be 1 millimeter each roughly. And yes, they are. If you're getting different blades, you could go up to a 12 millimeter root thickness, no problem. Now let's mount the blades on the head and see how they balance up. While the clear coat on the blades may not be the nicest, oh, the balance is bang on out of the box. As we can see here. So CG and blade weight, bang on. Very nice. Chapter 37 to 40 is now complete. That was installing the motor, and very straightforward. No real big issues there. It shows the wiring to exit on the left side of the outside of the frame here, and there's a protective hole for the ESC wiring to come through to hook up so the wires don't chafe on the sharp edges of the carbon. The only item that wasn't too clear in the instructions is how these locking nut set screws are fit. They've got a hex on one side, and it doesn't really say which way they go. And originally I had them upside down, and then you can't hold the set screw from turning as you're locking the nut down. And if that set screw drops, it's going to hit the main gear pulley. So yeah, you have to make sure as you're tightening those nuts, that set screw isn't threading down, damaging that gear. So the idea is you just get a 7 millimeter wrench, you hold the set screw from turning with your 2 millimeter hex, and then you tighten your 2 locking nuts down on the tray. This tray is sprung loaded. You just push it all the way in, you put the belt on, pull it back, and it will stay in that position. Tighten these 2 and then tighten your main lockdown nuts. The only other thing here is setting your height of your motor pinion. It's pretty easy. You just adjust it either up or down so the belt is running centered on the big drive gear. And yeah, you want that belt fairly tight. Just like the main rotor head, the tail rotor comes pre-assembled, but there's no thread lock, nothing's lubricated, so you have to take it all apart. Just like the main rotor, it's a dampened tail rotor. You don't often see that in lower cost kits, but your 2 radio bearings in each blade grip, they have to be glued in with your bearing retaining compound. They look pretty dry. I would probably recommend putting a drop of oil in each one after you get them in there and glued in. Of course, you're going to have to pack your thrust bearings, just like the big ones too. There's an inside race, which has got the larger ID, and the outer race, which has got the smaller ID. If you can't see the difference by eye, again, that's where digital calipers come into play. I've just cleaned all my screws up, the threads in the axle, just so the thread lock 242 will bond correctly. If you use 243, it's not as critical. Take your time with it. It's all little parts, but basically just a small version of the big rotor head. Chapter 41 to 50 of the build is complete, and that's the tail rotor assembly. It's more finicky than anything, but again, every fastener has to be removed and thread locked. That includes all the little fasteners on the belt, pulley, pitch slider, even the brass sleeve where it threads into the end of the pitch slider. Had to take that out and Loctite that into place. Just have to be really careful on the links that they're free to move. Make sure you don't get any thread lock in there. I actually use bearing retaining compound on these little tiny screws. They often back out, I find. The one thing of a little bit of concern is when you slide the pitch slider onto the shaft, it's actually quite a tight fit. The brass sleeve is actually rubbing on the shaft and it's actually grinding a little bit. Kind of explains it in the instructions not well. The idea is you're basically using the shaft to hone that sleeve for just an ideal perfect fit. So what I did is I just put oil on it and just ran that sleeve back and forth and basically honed it and sized it for the shaft. And the shaft has actually got quite aggressive turning marks on it. You can actually feel it with your fingernail. That aids, of course, in honing that sleeve, but it also holds oil then. All those little grooves will hold lubrication on the shaft. And once you get that done, it's just butter smooth. There's zero play in here. There's a couple of spacer washers that come with it, but I didn't have to use them. That just takes up any lateral play, but there was none once I got it all bolted together. Chapter 51 to 60 is now complete. We've fit the tail assembly onto the boom. The belt is in place. The push rod is in place. Just make sure it moves butter smooth. A little bit of advice here. Before you glue the threaded rod into the carbon fiber rod, I would thread the links so they're not as hard to screw on. They're very difficult to screw on afterwards, and I was worried that if the CA glue hadn't set up in time, I could strip it out of the carbon rod. Other than that, it went pretty straightforward. The most finicky thing was fitting the double-sided tape to the front screw mount brace, and then just aligning all the little plates inside so they'd line up with the hole. I put my little 1.5 hex through, and then I got the little plate with the double-sided tape on it, and then slid it over the shaft of the hex here so all the holes lined up. So you've got two in there, you've got the big one here. Oh, that was the other thing, this one back hole. I just had to get my Dremel with the sanding drum on it. It wasn't quite big enough for the metal insert to come through, so I just had to clean the hole up a bit. Didn't really take much material off, just cleaned the hole up. And then, yeah, there's more plates on the back here, and again, you just line them up till the double-sided tape stuck it to the inside of the carbon tube. Installing the boom onto the machine and fitting the belt. Nothing exciting there, went really very easy actually. Just got these two screws holding it in the top, and then these two side ones. When you fit your belt, you just want to make sure when the shaft is turning clockwise from the top, you want to see the front blade on the boom spinning up towards the rotor disc. So again, back blade's always spinning down, front blade spinning up on that. As far as tension goes, I set it moderately tight. It may stretch a little bit the first couple of uses, but I'm going to see how it goes with that. Setting the tension is really simple. Just loosen your 4 screws off back here and slide this forward or backwards. These thread into nylon lock nuts. Yeah, you don't have to worry about applying thread lock every time. So I'm pretty much done for tonight. Looks like they give you 1 spare parts bag with a couple of the big tail boom nylon shear bolts, a couple of the extra links, some of the little cup or beauty washers, and an assortment of hex bolts, a couple of nylon lock nuts. Really happy with it. It's turning out just great, and yeah, can't wait to get the electronics in. So, see you for today. Chapters 66 through 76 are now complete, and our third night of the build, and we're pretty much all finished. So just thought I'd go through what that entailed, and it was pretty straightforward. It's just mounting the remainder of the electronics. So the ESC, mounting the flybarless unit, getting all the wire management set, fitting your receivers. I've gone with two JR satellite RXs. I'll probably be getting an FR Sky X4RSB because this thing will handle S-Bus. So that way I could have telemetry. But I've got a bunch of these little satellites lying around, so I thought I'd just use those for the setup. I'll go over the setup real quick in a bit. The ESC was a little bit of a bugger to fit. It's got these 4 little mounting tabs on the front and the back. I had to cut the back ones off so I could slide it back as far as possible for 2 reasons. One, I didn't like the power caps sticking out past the front. I feel they're just a little bit more protected sitting back, but the main reason was the wiring from the ESC to get up to the flybarless unit. There's not a millimeter to spare, and with the RX or with the ESC slid just a few millimeters forward, I didn't quite have enough length of wire, so that's why I've sat it back. And also when it sits back like that, let's see if we can see underneath. Yeah, it sits right back against this brace, and it sits on the top of this front brace, and that gives it a slight angle. If you have it mounted on the top of both braces, you can't fit the battery tray in. It hits the top of the ESC. As far as the flybarless unit goes, in the manual, it shows the plug connectors at the back. I moved them to the front again to give that room. If they were at the back, I wouldn't have enough length from the ESC wiring, and also from servo 2 at the front here. By the time you route the wiring all the way around, it would not reach to the back. Of course, you've got plenty of lengths from servo 1 and 3. Now, as far as battery fitment goes, I'll show you the size here. So this is a 4000 6S pack, and it fits fine. Clicks in no problem. Lots of room. What you have to be careful with is this upper room between the motor belt pinion and the battery and the strap. Now, the sliding tray is real slick too. You've got this little release here. But I was hoping I could fit my big 5000s in there, and they do fit. Just to give you an idea of width, you've got about 53 millimeters. But it's the height you have to be concerned with, and that's the problem with this, because by the time when I put the strap on, the strap actually touches the bottom of the motor pinion. So I don't know how I could do that. And this battery, just to give you a reference, oh, and I don't even have Velcro, so that'll add in about another millimeter or 2. But as it is right now, this battery is roughly, about 51 millimeters. So yeah, anything really much more than 50 millimeters, you're probably going to hit that pulley. The only way I thought I could make it work is to actually use double-sided tape and adhere it right to the tray. But then, of course, you've got a battery that's dedicated to this machine on that tray. The other thing is, remember I mentioned that the head dampening, just the O-rings? There is quite a bit of, you can feel a bit of play in there. So if anyone wants to comment, if anyone's done one of these, if you've used those 2 hard inner ones with the O-rings on the outside, I'd just like to know what your thoughts are of it. I don't want super firm dampening, because then I have to run a super high head speed. Lower the dampening, the lower the head speed you can go without cyclic wobble. But I don't want to be having so much dampening that it feels sluggish and not crisp, and of course possible tail boom strike. So if anyone wants to comment below what they did for their dampening, I've got one spacer shim in there over and above the brass ones, like they mentioned in the instructions. The big showstopper now is, as I mentioned in the unboxing, you have to get the ESC programming box, the Hobbywing ESC programming box for this thing. So I'm just waiting for that. I ordered it about a week and a half ago, so it's probably going to be another week, 2 weeks to get here. I kind of wanted to finish this whole video with the first test flight, but I'm not going to be able to. We'll have to do that in a separate one. and I'll just go over the programming of the mini K-bar. The biggest issue with it was actually downloading the driver software. Couldn't figure that out for a good almost an hour, but other than that, no problem at all. Very intuitive FBL wizard to use. The VStabi setup wizard, as I mentioned, is very intuitive to use. It's easy to download off of their site. Biggest issue is installing the correct driver software, but once I got that figured out, it connected up fine. So there's basically two parts to this. There's the setup, and if you've set up a flybarless unit before, very similar stuff. First you select the type of receiver you're using.
High rates, rudder high.
You get out your transmitter to set, full, all your centering positions and 100% up and down, left and right. So you're basically just configuring the transmitter for the FBL unit, your sensor orientation, which way you've got it mounted, your main rotor direction, your servo layout for your swash plate. This is where you set your direction of your servos so they're all interacting in the right direction. Trim is where you center your servo arms, and then set all your geometry, and I'll show you that up closer. The geometry was perfect. And here you're setting your collective range, your cyclic range, and here you set your tail rotor servo direction and set your end limits of your tail pitch slider. I'm not using governor. And then the only other settings here, I just use the factory preset ones, and if you hover over each section it gives you a little information window. And I want my agility somewhere in the middle for sport type flying. This is the gyro gain for your cyclic gyros. Basically set it somewhere about in the middle, and then your tail rotor agility or yaw rate, and you can even go into advanced settings to really start playing around with the feel of it, but I'm just sticking with the factory suggested ones. It shows you the battery voltage, vibration, active vibration. If we tap on the FBL unit, you can see the vibrations coming up, and it'll show you the maximum as well. And then there's this auto trim. I guess if you notice it drifting in flight, you can go into this auto trim mode. You hover it for about a minute, very still, and it will automatically trim everything out. But if you've set everything up correctly, you shouldn't have a problem with that. And I just basically use my same instructions for setup on this as I do in my Swashplate setup and leveling ebook. Just thought I'd show you the head geometry here.
Gyro heading hold, rudder high, throttle hold.
So hopefully we can, let's just push that way. And we'll just go to mid stick. So you can see it mid stick. So level swash, 0% on the blades. These little hash marks work really well, and you'll see my full plus and minus range of plus minus 12 basically goes to the outer marks. So you could use those if you don't have a pitch gauge, but I used a pitch gauge, always best. But at 0 degrees, the washout arms are perfectly level, and I had to actually increase the length of the 3 Swashplate arms by 1 turn to get that arm level, and then of course reduce the distance on these 1 turn to bring the pitch back to 0 from what they had suggested in the manual. That was the only deviation there. You can see it'll spool up, sounds very smooth. Nice slow spool up. But just waiting for that ESC programming card, because I don't like this ELF governor mode that they've got set. I don't like the timing that they've suggested, and I'm going to bump up the voltage for the Beck. It's set at 6 volts. I'm probably going to go up to 7.5.
Oh yeah, that was the right switch.
So just thought I'd show you the finished unit with the canopy on. Canopy does fit really nice. The little rubber grommets slide over the pins quite easily. I lubed them up. I lubed the pins with some silicone grease, and they slide really nice. I did put that trim that came with it around the top here just to keep the finish from chipping as you insert it on and off. Put a little piece there too, just glued it with thin CA, just whipped it around, but really easy to fit it. And then you just use the little pins to hold it on. And I'll just finish up here by showing you the size difference between this, a 600 and a 450, just so you get a rough idea of sizing. It is a big 500. It's closer to a 550 in size. It's actually quite a nice size. I learned on an XL40 when I started this hobby 30 years ago, and this kind of reminds me of that size. This is close to it. If you're interested, there's a size comparison. 600's at the back, then the 505, a 450, and also just threw a little 250 in there. As you can see, the 505 is actually a little bit taller canopy-wise than the 600, but the rotor disc is sitting closer to the machine, so it's shorter in that respect. The head block's a lot shorter. So that's it for the build. Once I get that programming card, we'll see if we can get a test flight done. Cheers, folks. Have a good one.